So this is an exam question from 2018. All right, so we went through a bit of a matrix thing, but we can talk about that later anyway. So we're going to do it properly, so you're going to have to write your PN statement and all that jazz. Okay, so people are doing their thing. Hopefully they're not looking at the board, but we've got all of the basics. So P1, yep, that's true. It's divisible by 4. We want to assume PK true. Remember, you've got to put this here, blah, blah, blah. And because we're saying N is positive, we'll say A is as well, but could work for any. To prove PK plus 1, so we're trying to prove this. So I will somehow want to use my PK. Now, in order to do that, I would need to replace 10 to the k. I mean, I could replace 6 to the k if I wanted to, but I'm going to replace 6 to the k, 10 to the k. Unfortunately, I do not have a 10 to the k here. I've only got a 10 to the k plus 1. So what was that little technique that we had to do? Yeah, but how do I sub it? I have to split it first. Excellent. So that's 10 times 10 to the k. Minus, and you know, I can write 6 to the k plus 1, but we've done a few of these and we can see that we've got 6 to the k is there, so I might as well split that while I'm here. And now I'm going to have that's 10 times, now 10 to the k is going to be 4a plus 6 to the k minus 6 lots of 6 to the k. I'm looking at someone particularly in this class who's not looking at the board, Lamb, because he did not tell me. Using PK, I'm just doing it all on my own. I feel like I'm doing it on my own now, Lamb. You've left me. Okay, and we know that hopefully what is going to happen at the end, we should be able to pull out a common factor of 4. So I'm not going to say 10 times 4 is 40. I'm just going to say 10 times 4. Because remember, you might have in your test, it might be divisible by 17. So then it might be 17 times whatever. I think there was one, there's some in your books where it's got divisible by 27, all that sort of stuff. So I just keep it as, and there's no way that you would be able to say 10 times 6 is 60, that you cannot do that because one's got the power. You laugh, I have seen it done before. All right, and we're getting very happy here because 10 lots of 6 to the k minus 6 lots of 6 to the k is, oh my goodness, 4 lots of 6 to the k. So I can now pull out my common factor of 4, 10a plus 6 to the k. I will very nicely say that this bit here is an integer since a and k are integers, therefore pk plus 1 is true, i.e. it is divisible by 4. And insert statement here. Since p1 is true and pk plus 1 is true, whenever pk is true, then pn is true for all n positive integers by PMI. Don't forget to add on the by PMI, proof by mathematical induction. Yes, add that on. Sorry if I neglected to say that. By PMI. Yep. You can write PMI, you don't have to say it. Shh. Okay, so that's well and good. Let's go back up to part B. Okay, so hence, that is your tip. That is basically saying, please use that thing that we have just proved. So you must use this that we've just said equals 4a. Danny, Lamb, did you want to share? Who's freaked out? By the way, this was from 2018 exam, and they were very pleased with the fact that they've got 2018 there. They could have put any number they want. Boys, yeah? Shall I come to you? You don't have to speak into the mic, but no one knows.
Because the rule says that it equals 4a times 25 to it, and it will be 100a.
So, I love it. So this is basically your n. Yes? So what they're then saying is that 25, this thing here, must be divisible by 4. So it's 4 times something, so we can say that that would be 4 times A, and then 25 lots of 4 is 100, and so 100 times anything, as long as it's an integer, means the last 2 digits has to be 0, 0. So therefore the last 2 digits cute? I like it. Oh, that's not what I wanted. So we are now looking, this is recent, this is now, oh, come on, move, that's the way. We are looking at another exam question. Gentlemen at the back, why do we have the chapter? The reason that I'm saying you can skip the actual induction is because I feel, oh my goodness, you can do this in your sleep. But if you think, no, then by all means, feel free to do it. Oops, dropped my pen. I'm just getting, I like the part B for this. Sorry you're listening to me or watching me do this on the recording, but if I don't, I can't do the bits. So I feel that you would be able to do this. If you think you can't, as I said, in a minute, you can be quiet and I'll be quiet, and you can finish this. But would you agree? We have proved that this equals 3 lots of something, yes? So once again, they've gone, hence, show that 7 to the n take 1 is divisible by 3. You've got to use this to use this. Have a bit of a think. We're on the move. All right. So, oh, that's hard to read from back here anyway.
Yeah. Can you just say that because 7 to the n plus 2 is 3a, and then 7 to the n take 1 is just 3a take 3?
You most certainly can. So what I would be doing is we know that, so we know this, I would write this down, 7 to the n plus 2 equals 3a, and I'm going, well, how does that relate to this? And it would be, well, 7 to the n plus 2, if I took away 3, does that not equal this? So now I've got 7 to the n take 1 equals this, and what Keats was just saying is this bit here we know is divisible by 3. Agreed? So therefore, I can now pull out a common factor of 3, so that means that whole thing is also divisible by 3. So it's a great example of where you have to use this thing here, like write it down. How can you make it look like? Agreed? All right, what about part C? So the hence, once again, or didn't say hence, but it says use part A and B. So using part A and B, I've written them down. I know that this equals 3a. I know that this equals, I don't know, maybe the other way around. Sorry about that. So this is 3 times something. This is 3 times something. I want you to look at this. And what do we know about 9 and 3? Or 3 and 9? Keep going round. How can you turn, sorry, that writing is very bad. I apologize. So that's 3 times B. This will be 3 times A. How can we prove that it's divisible by 9? And look at this, 7 to the 2n. It's almost like you had 7 to the n times 7 to the n. So, thanks, Nails. That's exactly what we're going to do. So if I've got 7 to the n take 1 times 7 to the n take 2, what do I get? That's 7 to the 2n. 7 to the n times negative 2 is minus 2. Lots of 7 plus 2. Minus 1 lot of 7 to the n. Minus 1 times 2 is minus 2. And you go, oh, well, that's great. that actually gives us this thing here. Would you agree? Why does that prove that it is divisible by 9? Right. Excellent. Thank you. So they're saying, well, this would be 3a times 3b, or vice versa, which means 9ab, they're both integers, so it's divisible by 9. It said 9, not 3. Cute? So you've really got to make sure that you're reading those first bits and carry on. 2019 exam question. This one is worth 8 marks. So if you didn't remember this one from the other day when Sam was going through it, what was that question in our textbook? That was question number 3. 3b, if you have a look, it's reasonably similar. They've just gone 3/4, but you make these up, but it's all based on the one thing. So what I would be recommending is that you look at your right hand side and you can see that they've got 4/3 pulled out as a common factor. Agreed? So here I can see, well, I've also got 4/3 as a common factor for this bit here. But I haven't got it for the second bit. So what I'm going to do is I'm going to make it. I'm going to make it so. So I'm going to put a 4/3 there, right? But I can't just times something by 4/3 because I've changed the thing. So I'm also going to then times it by 3/4. Yeah? So times 4 to the k plus 1. So now I can happily pull out my 4/3 as a common factor. So I get 4 to the k, take 1. When I pull out this 4/3, I get a 3/4, which is not overly thrilling for me. However, it's not like this is a 5 or a 7 or something. It's a 4. This has got a base of 4. And remember, we can cancel, but before we do that, I'm going to split my 4 to the k thing, right? So are we happy? That's 4 to the k, take 1, plus 3/4. This would now be 4 times 4 to the k. This now means I can cancel happily the 4s, and we can read that as we've got 4 to the k plus 3 lots of 4 to the k. So how many lots of 4 to the k have I got? I've got 4 lots of 4 to the k. There's my take 1, and timesing by the same base, I add the power. I mean, there might be a shorter cut somewhere in there, but who knows. Therefore, pk plus 1 is true. And so P1, since P1 is true, and pk plus 1 is true whenever pk is true, then pn is true for all positive integers by
PMI.
proof by mathematical induction. All right, so well done to you, but now it's part B's time. Again, for those people who are looking at this and they can't see, don't just, yes, keep staring, but after, say, 30 seconds, you've got to try something else. So what could you do? Well, you can put that's 4, that's 16, this is 64, and so on. And then do you notice anything? It's, yeah, as Bowen said, we're just taking one every time. But what is it? You need to work out what your n is. So are we summing up to 10, 12, 13, 14, 15? So this would not be a great question for no calculator. Okay, so grab your calc. 4 to the what? So we've 4 to the 12 is 1, 6, 7, 7, 7, 2, 1, 6. Agreed? So how many times, what does that mean your answer is? So if we're adding all of these up, we're going n is 12. Do we just sub it in? You can sub it in, but you've got to do one extra thing. Just one? How many times have I taken 1 away? 12 times. So we're going to sub that in there, so it'll be 4/3. It'll be 4/3, 4 to the 12, take 1. But then I have to take away 12 because how does this relate to this? This became this one. I took 1, I took 1, I took 1, all the way up. How many times did I take 1? 12 times. So take. Right? So it's not a massive, long-winded thing, but look and see your connections. So with the division one, we were looking and going, okay, I've got 9, had the 7 to the 2n. How do I make it so? With this one, you're looking at your numbers. You might not have been able to see, so then play around with this. Do something. Don't just stare. Write something down.